Hi, and welcome to part 1 of grade 11 Euclidean geometry. In charge of the lesson is Benedict Seragwana, popularly known as Prof. In this video, I'm going to concentrate on two sections of Euclidean geometry, which is circle terminology and circle definition. And please make sure you understand everything that I'm going to discuss with you guys. Make sure, because these are kind of fundamental part of Euclidean geometry. The pillars of the topic. If you understand these things, you are laying a very good foundation of your Euclidean geometry, and it will be easy for you to understand. Trust me, going forward. And please make sure you own the information. That's all that I wanted to say, or I'm gonna say with you for now. Let us start with our lesson. So, like I said, I'm going to discuss two sections, which is circle terminology and circle definition. For now, I'm going to start off with circle terminology. Here are the terms that I'm going to discuss with you already down the circle, and please draw the circle, and please make sure you've got a pen and book ready, because whatever that I'll be discussing, some of the things I'm not going to really write them down. I will just define without writing them down. So please make sure that as I'm defining, you write the notes down. So number one, I'm going to discuss a radius. By definition, a radius is a line that is drawn from the center of a circle to the circumference. So that's what a radius is. A line that is drawn from the center of a circle to the circumference. So what I mean basically is, if I'm given a line, it doesn't matter as long as my line is drawn. Let me say O in this case is the center, and let me select some points on the circumference. I think you already know what the circumference is. Remember, the circumference is the round part of the circle. This round part simply represents what? The circumference. So if I've got a line drawn from the center to any point along this round part, that line will be called what? A radius. So let me just select maybe 2-3 points along the circumference. As you can see, let me call this A, B, and what? C. As you can see, A, B, and C are points along the circumference, and O in this case is the center of the circle. So if I draw a line joining O and C, what I'm going to produce here will be called what? A radius. Why am I calling this a radius? Because this is a line that is drawn from the center to the circumference of a circle. I can also have my line drawn like this. So this will also be what? A radius. I can have something like this. This will also be what? A radius. As long as I've got a line that is drawn from the center of a circle to any point of the, to any point along the circumference, then that would be what? Will be a radius. So our B will be a chord. Our B will be a chord. B will be a chord. A chord is a line segment. I think this one, let me just write it down. A chord is a line segment. Line segment. It's a line segment that joins 2 points on the circumference. That's how we define a chord. A chord is a line segment that joins two points. That joins 2 points on the circumference of a circle. That's how we define a chord. So before I define a chord, let's firstly discuss what is a line segment. A line segment is a line that joins 2 points. For instance, if you give me 2 points, let me say point P, and you give me another point here and call it point Q. If I draw a line joining P and Q, then that line will be called what? A line segment. So as you can see, this line is joining P and Q. Therefore, this line here will be called what? A line segment. So a line segment is a line that joins 2 points. But with a chord is a special line segment, because we are saying a chord must join 2 points along the circumference. If you look at this, P and Q are not points along the circumference. However, PQ is a line segment. But with a chord is a line segment that joins 2 points along the circumference. So it means in order for me to produce a chord, I need 2 points along the circumference, and those 2 points must be joined. For instance, if I'm given this point here as A and given this as C, you can see that A and C are points along the circumference. So if I draw a line joining A and C, then this line segment. If I have a line segment joining A and C, then this line segment will be called what? Will be called a chord. Why am I calling this line segment a chord? Simply because this line segment is joining what? 2 points along the circumference. Therefore, this will be what? Will be a chord. So that's what a chord is by definition. It's a line that joins 2 points along the circumference of a circle. So if you give me a point here, for instance, let me say this is B. If I draw a line joining C and B, BC will also be what? So if I draw a line segment joining B and C, this line segment will be what? Will be a chord. Why? Because B and C are points along the circumference, and BC is joining what? Those 2 points. Therefore, BC will be also a chord. So by definition, a chord is just a line segment that joins 2 points along the circumference. Similarly, if I join A and C, this becomes what? A chord, because A and B are points along the circumference. So that's what I mean by a chord. So let us go to the next one. The next one that I'm going to discuss with you will be an arc. Sorry, a diameter. Diameter. C, I'm going to discuss with you a diameter. C will be a diameter. What is a diameter? A diameter is a chord. A diameter is a chord that passes through the center of a circle. Diameter is a chord that passes through the center of a circle. Remember, we already know what a chord is. It's a line segment that joins 2 points along the circumference. It means a diameter is also a line segment that joins 2 points along the circumference. However, with a diameter, it must pass through the center of a circle. If we can look at this example here, I give you something like this. Let me call this AB. You can see that AB is a chord because A and B are points along the circumference, and AB is joining those 2 points. So AB becomes what? A chord. But can I call AB a diameter? No, it cannot be called a diameter. With a diameter, by definition, diameter is a line segment. So it's a chord that passes through the center of a circle. So it means it is not just a chord. It must be a chord that passes through the center. For instance, if you give me something like this, P, then I have Q here, and then let us say O is the center. O is the center. In this case, you can see PQ is a chord. If you can look at this, PQ is a chord because it's a line segment joining what? 2 points along the circumference. Therefore, PQ is what? It's a chord. But this chord passes through the center of a circle. Therefore, this type of a chord, it is called what? A diameter. It's not just a chord, it's a special chord. A chord that passes through the center will always be called what? A diameter. I can have something like this again. Something like this. You can see this is also what? A chord, because it joins what? It joins 2 points along the circumference and it passes through the center. Therefore, this chord will be given what? A name. So it will be called a diameter. A chord that passes through the center will always be called a diameter. So let us go to the next one. The next one will be what? A diameter. Sorry. The next one will be a chord. No, not a chord. An arc. An arc. The next one will be an arc. So that is D. So our D will be an arc. What is an arc? An arc is a portion. I think this one I can write it down. An arc is a portion of the circumference of a circle. So that's what an arc is. It's a portion. It's a portion of the circumference. You already know what the circumference is. Remember I said the circumference is the round part of a circle. But if you select a portion of that round part, you select a portion of that round part of a circle. Therefore, that portion will be called an arc. You can see now we've got the round part of the circle. So this is what is the circumference of the circle. But now here's the thing. What is an arc? I said an arc by definition is a portion. It's a portion of the circumference of a circle. So let us look at this. If I select, I'm going to select just a portion here. I can, let me just take this portion here. If you look at this portion here, This is a portion of what? Of the circumference of a circle. This is not the entire round, it's just a portion. But it's part of what? Of the circumference. It's a part of the circumference. Therefore, this portion will be called what? An arc. It will be called an arc. Even the remaining one, if you look at this black guy here, the remaining black guy here, this is also a portion. It doesn't matter how big it is. It may be very big, but if it is not making the entire circle, therefore, it is not making the entire round part, therefore it does not become what? It doesn't become the circumference. It is just a portion of the circumference. So it means in this case, the black guy here is also what? An arc. So I've got this arc, I've got what? This arc. The smaller arc is always called what? A minor arc. The smaller arc is called a minor arc. And the bigger arc is called a major arc. So the black one becomes what? A major arc, and the smaller one becomes what? Becomes a minor arc. So that's what an arc is, a portion of the circumference, not the entire circumference, just a portion. Just a portion. So let us go to the next one. The next one becomes a segment. Segment. What is a segment? I spoke about a segment earlier, but I was talking about a line segment. There is a line segment, there is also a circle segment. So in this case, I'm going to talk about what? Circle segment. A segment of what? Of a circle. How do we define a segment as far as a circle is concerned? We say a segment is a portion. Let me just write it down. A segment is a portion of a circle. Is a portion of a circle that is cut off by a chord. That is cut off by a chord. So that is what a segment is, as far as a circle is concerned. So a segment of a circle is a portion of a circle that is cut off by a chord. So that's what a segment is. So now, let me give you an example of what I'm talking about here. Let me have a circle here. But before I go any further, let us just talk about, let me just cut a simple portion this way. So this guy here, if you can look at this is a portion of a circle. It's a portion, it's part of the circle, this one. It's a part of the circle. But can I call this portion a segment? No, I cannot call it what? A segment. If you can look at Peter takes a shape of a circle, and every piece that you eat there becomes what? A portion of that particular circle. But those portions are not called what? They are not called segments. Those are called sectors. Those are just what? Sectors. But I'm not going to discuss that. For now, I want us to concentrate on what? On the important terminologies. So let us talk about a segment. A segment is a portion of a circle that is cut off by a chord. For instance, if I draw a chord like this, you can see this segment, it is cutting or dividing our circle. It's cutting our circle into what? Into two pieces. There's this piece here. There's also what? This piece here. So each portion here will represent what? A segment. Because these portions, each of them is cut off by a chord. If you look at this portion here, the smaller one, the smaller portion, it was cut off by a chord. So when you introduce a chord will cut a circle into two parts. And each part in that case will be what? A segment. So it means in this case, this portion here, I can call it what? A segment. Even the remaining portion here, this is not a full circle, it's a portion of a circle, and it was also cut off by a chord. So it means this will also be called what? A segment. The remaining, the bigger guy here. So in this case, so for every chord, there will always be what? Two segments. It will depend on how the chord is drawn. So I'm not going to say the bigger and the smaller. It depends on the situation. So now in this case, we say the smaller segment is a minor segment. The smaller segment is a minor segment, and the bigger segment is a major segment. So that's what we mean by a segment. It's a portion of a circle that is cut off by a chord. So I need a chord in order for me to have what? A segment. if you look at this, it doesn't matter how the chord is drawn. I can draw a chord like this. This thing is a chord. For every chord, every time when a chord is drawn, it will divide or cut a circle into two pieces. So you can see this chord is now cutting my circle into this piece and this piece. Can I call this a segment? Yes. Can I call this a segment? Yes, because both are cut off by what? Are portions of circles that are cut off by a chord. This guy is a chord here, cutting what? A circle into this portion. So this portion is a minor segment. And then the other portion will become what now? A major segment. So that's what we mean when we say a segment. So there's a minor and a major in this case. Guys, remember I just discussed with you that a diameter is also a chord. So it means even a diameter, when it is drawn on a circle, it will cut a circle into two pieces, and each piece will be called what? A segment. Because by definition, it's a diameter, not a chord. It is a chord, just that it's a special one, but it is a chord. It doesn't change that fact. So a diameter is also what? A chord. So if you give me a circle, and on that circle you introduce a diameter, you can see my diameter. Now let me call it AB, and have this as what? As my center. You can see that AB is a diameter because it's a chord which passes through the center. So now, remember, is diameter not a chord? It is a chord. It doesn't matter whether it passes through the center, but it is still what? A chord. So, can I say this chord, if it is drawn, can I say this chord is cutting off my circle into segments? Yes. When a circle is cut off by a chord, it will always produce what? It will always produce two segments. It doesn't matter whether your chord is a diameter or not. Any chord, special chord, no special chord, every chord will always divide a circle into two segments. So it means in this case, this portion here will be called what? A segment. Even this portion here will also be called what? A segment. Because each of this portion was cut off by what? By a chord. But that chord in this case is what? It's a diameter. But in this case now, if you compare, in this case, in a case where the chord is a diameter, there is no a segment that is going to be minor or what? Or major. The segments in this case are said to be equal to each other. A diameter will always divide a circle or cut a circle into two equal halves. So this part and this part are halves of what? Of the circle. So this and this guy are what? Are equal. Each represent what? Each represent half of a circle. So in this case, the name given to this segment, it is not, I'm not going to call this segment a major segment or a minor segment because the segments are equal. So in the situation where the segments are equal, the segment will be called semicircle. Semicircle. And then this will also be called what? A semicircle. So that is when a circle is being cut off by a diameter. If a circle is cut off by a diameter, then the segments created each will be a semicircle. Let us go to the next part of our terminology. The next part will be a tangent. What is a tangent? What is a tangent? By definition, a tangent is a line. Tangent is a line. That touches. Is a line that touches a circle at one point. At one point. That is how we define a tangent. It's a line that touches a circle at one point. So what does that mean? If you give me something like this, for instance, you give me a line like this, can we call this line a tangent? No, this cannot be called what? A tangent. Remember, with a tangent must touch, not cut through. So with this line cut through the circle, not touch. But with a tangent must touch. It will be something like this. Okay, it may not be perfect, but something like this. Yeah, it touches there. Therefore, this line here will be what? Will be a tangent. A tangent must touch a circle at one point, not cut through a circle. So with this one, it's cutting through. So this cannot be called what? A tangent. It's just a line. So there is one terminology I did not discuss here because it's not always there, man, in Euclid, you know. But I'll just explain it. That is EF. I didn't include it there. So F is a secant. Secant is a line. That cuts a circle at 2 points. It's a line that cuts a circle at 2 points. So that line, so it's called what? A secant. Let me erase the tangent here just to explain what I mean by secant. So if you give me something like this, for instance, something like this, you can see this line is cutting the circle at this point and this point. Therefore, this line is called what? It is called a secant. It's a line that cuts through. So cut the circle at 2 points. So I think we are done. Actually, we are done with the circle terminology. Let us now go to the next part of our definition. So of our part 1. The next part will be circle definition. Guys, make sure you draw the circle and the terminology inside there. So these things are very, very important. Trust me, you have to trust me, they are very, very important. You will never go wrong if you are to study. You will never go wrong. So the next thing that I'm going to discuss with you is circle definition. Circle definition. Circle definition. So here there are 4 things actually that I'm going to discuss. There are 4 things that I'm going to discuss with you. Number 1 being an angle at the center. Angle at the center. At the center. Angle at the center. How do we define an angle at the center? An angle at the center is an angle with these ones, I will write them down. Is an angle with its vertex at the center. At the center. And its arms as radii. So that's how we define an angle at the center. Angle at the center is an angle with its vertex at the center and its arms as radii. Before I can give you an example, or rather explain the meaning of this, there are 2 things that I would like us to look at first, which is vertex and arms. What are the meaning of those 2, guys? What is the meaning of vertex? A vertex is the point of intersection where the lines that are forming an angle intersect. Remember, in order for an angle to be formed, I need 2 lines to intersect. And then the space inside will become what? An angle. For instance, if I draw a line like this, ta-da, ta-da, you can see these 2 lines are intersecting here. Therefore, the angle will be formed. This becomes what? Our angle. And the point where the lines are meeting, it is called what? A vertex. So a vertex is the point of intersection of the points, so of the lines that are forming that particular angle. So by arms simply means the lines that are forming that particular angle. which lines are forming this angle is this line and this line. Therefore, these two lines are the arms of these lines that we have here. So this becomes what? An arm. This becomes an arm. Then the angle is what? The angle is formed. So the angle is formed. Then we've got the vertex of the angle and the arms. Here's the thing. Can I say this angle that we're having now is an angle at the center? No, it does not satisfy what? The definition. The definition says an angle at the center is an angle with its vertex at the center. So it means the first thing that I need to do, I need to ensure that the vertex of that particular angle is at the center in order for it to be where? At the center. So I must start off with what? With the vertex. However, two conditions must be met in order for an angle to be at the center. But my starting point, the moment you talk about an angle at the center, I'm going to check its vertex to check whether the vertex is at the center or not. If the vertex is at the center, then I will go to condition number 2. I'm going to check what? The arms. The arms must be radii. So it means each arm must be a radius. Now let us check. Let me give you an example of an angle at the center. For instance, if I'm given something like this, let me say we have and then this becomes what? Our center. Let me call this what? O. I'm going to give you two angles with the vertex at the center. And then there is also this one. But it's, let me have it this way. So this is angle O1, this is angle O2. Let me say this is A, B, and then we have what? C here. Let us look at these two angles. Let us start off with angle O1. It's angle O1 at the center. The only way I can know that is by checking these two conditions. Is by checking the vertex if it's at the center and also checking what? The arms if they are what? Radii. So if I do that, then I can say yes, the angle is at the center if and only if these two conditions are met. So now let us start. We are looking at angle O1. Remember I told you the vertex of an angle is the point where the angles are intersecting. So it's the point where the lines that are forming or the arms intersect. So now, where are these arms intersecting? They are intersecting where? At point O. Is O not the center? It is the center. So it means in this case, the vertex of angle O1 is at the center. So this is the vertex here. So this is the vertex. Is the vertex at the center? Yes. But now, is this condition enough for us to say yes, the angle is at the center? No, it is not enough. We must go to condition number 2. The first condition, yes, it's met. That is the starting point. Is the vertex at the center? Yes. But are the arms of that particular angle radii? Is each arm a radius? Let us look at the arms now. What are the arms of angle O1? The arms of angle O1 is OA and OB. Is arm OA a radius? Yes, because you can see OA is drawn from the center to the circumference of a circle. Is the other arm a radius? Yes, it is also drawn from the center to the circumference of a circle. Therefore, angle O1 is an angle at the center simply because both these conditions are met. The vertex is at the center and the arms are what? Are radii. But if we go to the next one, which is angle O2, let us look at angle O2. The first thing we check, of course, following the definition, is the vertex. Is the vertex of angle O2 at the center? Yes. You can see the arms of this angle are meeting where? At the center. Therefore, the vertex of angle O2 is at the center. Now, can I say angle O2 is at the center? Not as yet. I need to confirm now with the second condition. The second condition says the arms must be radii. Let us look at the arms. What are the arms of angle O2? The arms of angle O2 is what? Is OB and OC. Is OB a radius? Yes. But is OC a radius? No. Therefore, angle O2 is not an angle at the center. So that's what we mean. So you check the vertex and the arms. The vertex must be at the center and the arms must be radii. Then that angle will be at the center. You don't only concentrate on the vertex. I need both the conditions to be met. So now let us go to the next one. The next one is angle at the circumference. Angle at the circumference. So that is B under circle definition. B is angle at the circumference. Which is an angle with its vertex, so with its vertex at the circumference. And its arms as radii. Chords. As chords. Exactly. So that's how we define an angle at the circumference. That's how it is defined. So now, let us go to it. What is an angle at the circumference? It's an angle with its vertex. We already know what a vertex is. It's an angle with its vertex at the circumference and its arms as chords. So here, the key points are vertex and what? And chord. Arms. Again. Let me give you an example. So it means with this angle here, unlike the first one we said the vertex must be at the center. With this one, we are saying the vertex must be where? At the circumference. So it means if you want to talk about an angle at the circumference, the first thing you need to look at is the vertex of that particular angle. Is the vertex of that particular angle at the circumference or not? So let me give you two angles that are having vertex at the circumference. Let me come like this. Yeah, put it like this. So P, Q, R, S. So I want us to look at this angle here as well as this angle here. We can start with angle Q. Is angle Q an angle at the circumference? There's only one way to find out. Are these two conditions met? If they are met, yes, it is at the circumference. If they are not met, then it is not at the circumference. Let us check. So I'm going to start off with the vertex. Is the vertex of my angle, because the definition says the angle is, or is an angle with its vertex at the circumference. So is the vertex of the angle at the circumference? Let us look at the vertex. Remember, we know what the vertex is. The point of intersection of the lines that are forming an angle. The corner of the angle. So now, where are these two lines? So what are the arms? What are the arms of this angle? Here's the angle. This is the angle we are looking at. Is the vertex of this angle at the circumference? Yes, you can see the vertex of the angle is where? It's at the circumference. So this is the vertex here. It's at the circumference. Now, is that enough for us to conclude? No, it's not enough. What are we left with? We are left with the arms. Are the arms of this angle chords? Do we know what a chord is? Yes, it was discussed under what? Under circle terminology. So, as you can see here, let us go to the arms. What are the arms of angle Q? The arms of angle Q is what? Is PQ and QR. Is PQ a chord? Yes, because it's a line segment that joins 2 points along the circumference. So this guy is a chord. This is also a chord. It is joining 2 points along the circumference. So therefore, it means the arms of angle Q are what? Are chords. Therefore, two conditions are met. In this case, we can say angle Q is an angle at the circumference. Why? The vertex is at the circumference and the arms are chords. But if we go to angle R, is the vertex of angle R at the circumference? Yes, the vertex is at the circumference. You can see here's the vertex, the corner of the angle. The vertex is at the circumference. Now let us talk. What about the arms? Are the arms of this angle? The first condition is met. Let us go to the second condition, the arms. Now we go to the arms. Are the arms of this angle chords? Let us look. What are the arms? The arms of this angle is RS and QR. Is each arm here a chord? Is QR a chord? Yes. Is RS a chord? No. Is angle R at the circumference? No. Only one condition was met here. Then the angle is not at the circumference. So that's what we mean when we say the angle at the circumference. So with this one, it's all about, so with these two angles, it's all about the vertex and the arms. With radius, the vertex must be at the center. So with central angle or angle at the center, the vertex must be at the center and arms must be radii. But when we come here, angle at the circumference, the vertex must be at the circumference and the arms must be chords. We are done with that one. Let us go to the next one. The next one that I'm going to discuss. Like I said, I'm going to discuss only 4 things here. C angle subtended by a chord. Angle subtended by a chord. Before I start or define angle subtended by a chord, let me start off by explaining what it means by angle subtended. Let us start off by looking at angle subtended. What do we mean when we say angle subtended? Let us start here. I'll try to be as easy as possible here so that you can easily understand. I don't like complicating things. When we talk about angle subtended, we are talking about the angle that is being enclosed. We are talking about an angle that is being enclosed. NgesiZulu bathi ukuvalelwa. An angle that is enclosed. Let me give you an example of an angle. We already know that in order for an angle to be formed, we need 2 lines intersecting. So now in this case, let us say the angle we have, let me call angle Z here. If we look at angle Z here, is angle Z enclosed? No, it is not enclosed. Like I said, subtend simply means what? To enclose. So the angle must be enclosed. I would like you to think about your angle as a, let me say a dog. I would like you to think of your angle as a dog. This is a dog you want to enclose. You don't want this dog to go outside. To ensure that the dog does not go outside, you can close the exit for the dog. You can see there's a space here for the dog to exit. So the dog will exit somewhere here. So this becomes the exit of the dog. But if you close the exit, we say the dog is now enclosed. So when I say enclosed, so I want you to think about your dog as what? So your angle as a dog. Think about the dog you don't want to go out. So to subtend simply means what? To enclose. So in this case, Z is now being enclosed, which simply means what? Z is now being subtended. So that's what we mean by what? By subtend, just to enclose something. If you enclose something, you are subtending it. So in geometry, things we use to enclose an angle is either we use a line segment or we use an arc. So I will now explain this using what? A line segment and an arc. Let me start with a line segment. I already told you what a line segment is. I said a line segment is a line that joins 2 points. So A, B here becomes what? A line segment AB. So this becomes what? A line segment. So if I want this line segment to enclose a particular angle, to subtend a particular angle, this is what should happen. Let me say I have an angle here. This is the vertex of the angle. Let me call this angle Z. So this becomes what? Its vertex is fine. So Z is the vertex of a particular angle. So now I want angle Z to be enclosed by what? By AB. This is what you should understand. If you want an angle to be enclosed by a line segment, we say the arms of that particular angle must touch the end points of that particular line segment. The end points of AB is A and B. So this is where our line segment ends. So these are the endpoints. The start and the end are the endpoints of a chord. So if I want angle Z to be subtended by line segment, if I want line segment to subtend angle Z, it means the arms of angle Z, they must touch A and B. So I'm going to draw the arms. This is the first arm. Ta-da. And then here's another arm. Ta-da. Now you can see, these are so this becomes what? Angle Z. Are the arms of angle Z touching the end points of line segment AB? Yes. So this is an end point. This also what? An end point. So this is an arm. This is an arm. So let us look at each arm. Is this arm touching an end point of line segment AB? Yes. It touches what? A. And the other arm touches what? B. Therefore we say AB subtend angle what? Z. AB enclose angle Z. So that is how a line segment can enclose an angle. The arms of that particular angle must touch the end points of that particular line segment. Similarly, I can have an angle here. Let me call this the vertex X, angle X. If I want angle X to be subtended by AB, or I want AB to enclose angle Z, the arms of angle Z must touch A and B. I don't know if I'm making any sense. The arms of this angle must touch A and B. They must touch the end points of that particular line segment. So now, let me have the first arm. The first arm will touch A, and the other arm must touch B. In this case, we say angle X is also enclosed or subtended by line segment AB. So that is how a line segment, an angle can be subtended or enclosed by a line segment. I can't say line segment PQ. I can't say line segment PQ subtend angle let me say angle T. If the arms of T, for instance, something like this. In this case, yes, the angle is being enclosed. But can I say angle T is being enclosed by line segment PQ? No. Why? Because the arms of angle T are not touching the end point of line segment PQ. It's only one arm which touches the end point, but the other arm is not touching the other end point. Therefore, this angle is not enclosed by what? By line segment PQ. It is enclosed by P, whatever the point it is here. So if maybe this was let me say x, then I would say angle T, it is enclosed by px, because you can see that the arms are touching P and what, and X. Therefore, this becomes what, the end points of line segment PX. So that's what we mean by what, by a line segment subtending an angle. So let us go to an example of a situation where an angle is being subtended by an arc. Even an arc can subtend or enclose an angle. We already discussed. So I'll give you two examples where the angle is being enclosed by a minor arc, and the situation where the angle is being enclosed by a major arc. So here is the minor arc. Okay, it's not perfect. Let me have something convincing. Yeah, something like this. Let me say this is X. Let me say this is what, T. So this is minor arc XT. It's minor arc XT. And then I want this arc to subtend angle B. Similarly, an arc also has got the end points. This arc starts here and it ends here. So X and T are what? Are the end points of this arc. X and T are the end points of the arc. So if I want angle B, so this we're having here is the vertex of angle what? Angle B. So if I want angle B to be enclosed or subtended by XT, what I need is the arms of angle B touching X and T, because X and T are the end points of my arc. Something like this. Ta-da! Ta-da! Exactly. So in this case we say arc XT subtend angle B. Arc XT subtend angle B. I can also have another angle here. Let me say this angle here is C. So if this is the vertex of angle C. So if I want angle C to be subtended by XT, the arms of angle C must also touch the end points of this arc. So that's how it works. Therefore, this angle is also subtended by arc XT. Minor arc actually, minor arc XT. So that's how an angle can be subtended by an arc. That's how an angle can be subtended by an arc. Yeah, ta-da. Let me have something like this. I can even have a major arc. A major arc can also subtend an angle. Let me have it like this. Yeah. So this is also an arc. It's a major arc. So I can have this subtending an angle, depending on where the vertex is. So I can have my vertex somewhere here of the angle. So this becomes what? The vertex of the angle. Or I can have my angle somewhere here. So the vertex. Okay, let me start with this one. So this is the vertex. Let me call this S. So this is X, T, and X. So here is the angle. So this is the vertex of the angle. There's something that I want you to remember that was covered in lower grade, where you were discussing a revolutional angle around a point. So when two lines intersect, there will always be two angles. There will always be, if they intersect without overlapping. In this situation, there will be what? There will be two angles. And then there's also what? This angle here. So this is another situation where, so these are the type of angles we're talking about. So now, in this situation, what I'm going to give you two examples. So you'll tell me which angle is being enclosed. I'm going to draw, remember, this is the vertex of the angle. So this is the vertex of the angle. And I want my angle to be subtended by this major arc XT. So remember I said if I want an arc to subtend an angle, the arms of that angle must touch, the arms of that particular angle must touch the end points of that particular arc. So I can have, so now I'm going to draw the arms. So it means one arm must touch what? X, and then the other arm must touch what? T. The question is, because there are two angles here, which angle is being enclosed by this arc? Is it this angle or this angle here? Let me use red to indicate the other angle, because in this case you can see there are two angles. There is also this angle. So which angle in this case? Let me call this angle S1 and then call this angle S2. So between angle S1 and angle S2, which one is being enclosed by this arc? Is this angle? This one you can see is not enclosed. There's an exit here. So this angle is not the one that is being enclosed. The angle that is enclosed is what? Is this one. So this angle is enclosed by this. So there is no exiting. So you can, if the dog was inside here, there's no way in which the dog was gonna be able to go outside. But if the dog was somewhere here, the dog can be able to go outside. So this angle is not enclosed, but this one is what is enclosed. So you must be careful about that. But some of the things I'll discuss them as we proceed. I'll discuss them as we proceed. So I can also have an angle here. Let us talk about this angle here. The vertex, let me call this Z is fine. Z is fine. Obviously, if I want this angle here, so this is the vertex of the angle. If I want this angle to be subtended by xt, again, the arms of this angle must touch what? X and T. So now, remember there are two angles here, but let me talk about this one. So this is the angle that will be enclosed by this arc. The other angle, which was going to be this side, is not enclosed. It's outside, you can see. It's not enclosed. So this angle in this case is the one that is being what? Is being subtended by the major arc xt. So the angle that are being subtended by this major arc xt is angle S1 and angle what? Angle Z. This Z, ST, yeah, this Z, yo, Jehovah. Yeah, this Z here. So it's fine, let me leave it then for now. Let us go now to our definition. So the first one we say, erase here. So now you understand what we mean by subtended. So let us go to the next one. The next one, so okay, let me define angle subtended by a chord. We say an angle is subtended. An angle subtended by a chord is an angle with its arms. Is an angle with its arms. Let me use this one. An angle subtended by a chord is an angle with its arms touching the end points of a chord. An angle subtended by a chord is an angle with its arms touching the end points of the chord. Is an angle with its arms touching the end points of the chord. So we already know, remember a chord is a line segment. So the same way I was explaining using a line segment is the same way I'm going to explain using what? A chord. A chord is a line segment. Just that with this one, the end point lies along the circumference. The end point lies along the circumference, unlike the first one. So now here's the thing. Let me explain it. So here I'm going to need a circle. And then I'm going to draw a chord. Let me call this chord AB. And have an angle. Let me have it, let me just have it here. So this is T, and then this becomes what? The vertex of angle T. So this is the vertex of angle T. If I want this angle here to be subtended by chord AB, what should happen? We already discussed, or like we said here, an angle subtended by a chord is an angle with its arms touching the end points of the chord. So it means if I want this chord to subtend an angle at T, to enclose angle T, the arms of this angle must touch A and B. The arms must touch A and B. Guys, similarly, in this case, A and B are the end points of the chord. End points. So this becomes what? The end point. End point. So in A and B are the end points. So it means the arms of angle T must touch A and what? And B. So in this case, I say angle T, which is this angle here, is being subtended by chord AB. I can have another angle perhaps here on the circumference. Let me call this angle X. So this is the vertex of angle X. So now here's the thing now. If I want AB to subtend an angle at X, what should happen? Of course, I need to draw what? And the arms of angle X must touch A and what? And B. So in this case, we say angle X is being subtended by chord AB as well. So it means in this case, chord AB is subtending angle T and angle X, which is this X here. So these two angles are being subtended by what? By chord AB. I can have another angle here. Ta-da. Have another here. Let me say this is Z. So Z is also subtended by chord what? Chord AB. Because the arms of angle Z, which is AZ and ZB, are touching the end points of chord AB at A and B. So that's how it works. But the good thing about this one, unlike just a line segment with a chord it's very easy to identify, or rather see, whether the angle is being subtended by a chord or not. It's very easy. It's very easy. Okay, this is me just trying to explain the definition. But this is also me now being able to identify it in a quicker way. So the best way to identify an angle subtended by a chord, the good thing about a chord is that the end points of a chord are always along the circumference. So in other words, the only time an angle can be subtended by a chord is if its arms from the vertex, if you follow the arms from the vertex, those arms, they must touch the circumference of a circle, because that's where the end points of a chord will be. For instance, if you look at a situation like this, let me say I want to see whether this angle here is being subtended. So what I need to do is to follow the arms. Let me have the arms here, and then have the other arm ending somewhere here. Here's my angle that I'm talking about here. So this is the vertex of the angle. So I'm going to move from the vertex following the arms now to see if the arms are going to touch the circumference. And each arm must touch the circumference if the angle is to be subtended by a chord, because the end point of a chord will always be along the circumference. So now let us follow the arms. The first arm, so this arm here, this arm touches the circumference where here. Let me call this angle, so this point A. But the other arm ends here. Is the other arm, let me call this C. Is the other arm touching the circumference? No. So in this case, there's no way we can think. And then if I draw a line joining A and C, can I say angle T is being subtended by a chord? No. Wow, you can see. This guy is not a chord. And the easiest way to see is if the arms are not touching all the arms must touch, both the arms must touch the circumference. If this touches the circumference and the other one is not touching, therefore there's no way the angle can be subtended by what? By a chord. But if you give me something like this, let us say the other arm was ending somewhere here. And then let me say this is B. Now, by looking at this, are the arms of angle T from the vertex, are the arms of angle T from the vertex touching the circumference? Yes. You can see as you follow them from the vertex, this arm touches the circumference at A, and the other arm touches the circumference where? At B. So when you've got a situation like this, you can now think about what angle subtended by a chord. But it will only work if and only if these 2 points are being what? Joined. There is a line segment joining. So if you introduce a line segment joining these 2 guys, then now I can see that my angle, so AB becomes what? A chord. And the point where this arm touches A, so the circumference becomes what? An end point of this chord. And the point where this guy touches the circumference becomes what? Another end point. Therefore, this angle is subtended by this chord. So what I'm trying to say to you is I can only think about angles subtended by a chord if and only if the arms, when you follow them from the vertex, touches the circumference, and the point where they touches the circumference, those points are being what? Joined by a line segment. So that's how it works. You can give me an example like this again. Let us look at this. Tada. Let us say this angle is P, and then I have Q, I've got R. Now, let us talk about this angle. Let me say there's a line, of course, here joining RQ. So what I'm going to do, before I can even think about what a chord, the first thing I need to do is to follow the arms of my angle. So this is the angle I want us to look at. Is this angle subtended by a chord or not? The only way I can be sure is if the arms are touching what? The circumference, if I follow them from the vertex. Where is the vertex of this angle? This is the vertex. Now I need to follow the arms. Moving from what? The vertex. I'm following the arms, moving from the vertex. So I'm going to follow the first arm. The first arm touches the circumference where? At Q. And then the other arm touches the circumference where? At R. Is there a line joining those 2 points? Yes. Therefore, this angle is subtended by a chord. That's how it works. That's how it works. So now let us go to the next one. The next one is an angle subtended by an arc. It's an angle subtended by an arc. Guys, remember, with practice, these things becomes even more easier. Don't think after these lessons you already know Euclid. Here I'm just giving you the basics. That is me just introducing Euclidean geometry to you. So an angle subtended by an arc. Is an angle with an angle subtended by an arc is an angle with its arms touching the end points of an arc. I'm not going to waste any time. You already know what an arc is, and you know an arc has endpoints. I already explained this. Just that now I'm just going to have what? A full circle. So I'm going to select an arc here. Yeah, there's a point here, and then a point here. If I move along the circumference of a circle from A to B, this becomes what? An arc. From A to B, this is a portion of the circumference. It's not the entire circumference, it's an arc. So let us say there's an angle somewhere here, and this angle is called W. And I want, so this is the vertex, of course, of the angle. If I want arc AB to subtend an angle at W, or I want the angle at W to be subtended by this arc, what should happen? I told you that an arc can only subtend an angle if the arms of that angle touches the end points of that particular arc. Now let us look at this. So it means if I want my angle to be subtended at W, I'm going to draw a line joining, so touching the circle. So this is the first arm. The first arm must touch the end point of this arc, and then this one must also touch the end point of the other arc. It must touch the other end point of the arc. So now, can I say angle W is being subtended by this arc? Yes, because the arms are touching the end points of the arc. So that's how it works. That's how it works. That's how it works. I can also have another angle somewhere here, for instance, somewhere here. If, say, perhaps my angle, let me say the angle was at the center. Let me say the angle was at the center. Let me call this angle O. So if I want my arc to subtend an angle at the center, of course, the arms of the angle at the center must touch the end points, of the arc. Something like this. Then you can see this angle here is being subtended by this arc. So that's how it works. As long as the arms of that particular angle are touching the end point of that particular arc, then we say the angle is being subtended by an arc. Similarly, what I like about this, because when the key point here is what? The key point, if you can check properly, the key point is the end point in each case. When you talk about a chord, the key point is what? Is the end point. You talk about the arc, the key point is also what? The end point. If you talk about an arc subtending an angle, or a chord subtending an angle. And the good thing about those endpoints for both the chord and the arc, the good thing is those endpoints always lies along the circumference of our circle. So it means even with this situation, like I've been saying with a chord, even here, a situation where an angle is subtended, the easiest way to see whether the angle is being subtended by an arc or not is by simply following its arms from the vertex. An angle that is subtended by an arc will always touch the circumference that will have its arms touching the circumference if you follow those arms from the vertex. For instance, if you give me an angle here, let me say this is angle. Let me just say Q. Oh, this is the vertex. So this is the vertex of what? Of angle Q. So if I want to know whether this angle here is being subtended, if I want to know whether this angle is being subtended by an arc or not, the only way I can find out is by following the arms of the angle. If we follow the arms and the arms do not touch the circumference, then that angle is not subtended by the circumference. So let us follow the arms. So now I'm going to give you the arms. So I'm going to draw the arm like this, and then the other arm like this. Let us follow the arms. And let us say the point where this arm, but before we go there, and then this is our angle. Are the arms of angle Q touching the circumference of a circle? If they are touching the circumference, now you can think about what your angle either being subtended by a chord or subtended by an arc. Because that's where the end point of both the arc both a chord and an arc will always lie. The end point of those will always be along the circumference. So now let us look at this. If I follow this arm, is this arm touching the circumference of a circle? Yes. Where? At this point. Let me call this point W, Y. And then is the other arm touching the circumference? Yes. Where? At this point. And then let us call this point let me call it, what is this? Why would this is Y. Y. And then let me call this S. Now let us look at this. Can we now say this angle is subtended by an arc or a chord? Guys, remember, as long as the arms, as you follow them from the vertex, if the arms touches the circumference, think about your angle either being subtended by an arc or a chord. So in this case, are the arms touching the circumference? Yes. Where? At W and S. Now that's where you check to conclude whether the angle is being subtended by an arc or a chord. If there is not a line joining these 2 points here, if there isn't a line joining the point where the arms touches the circumference, then we say the angle is being subtended by an arc. Because in this case, you can see YS becomes what? An arc, and Y and S becomes what? The end points. So, is there a line joining the 2 guys here? No. Therefore, this angle is subtended by an arc. But if there was a line joining the 2 points where the arms touches the circumference, Therefore, in this case, you will say the angle is subtended by a chord. So that's how it works. And I hope, guys, you understand everything that I discussed in this video. So these are the things. So this was the last one. So these are the things that I wanted you to know, rather, in part 1 of Euclidean geometry. I hope you enjoyed the lesson and understood everything that was discussed. And please, guys, make sure the information is, you own the information, and please share the videos. Let others know about these lessons that I'm conducting, and please don't forget to subscribe and encourage your friends, relatives, everybody you know who's doing math, grade 11 and grade 12 as well as grade 10. Just encourage them to join the channel so that they can learn as much as they can. In this case, I will be, guys, in my videos I will be introducing every topic. I'm going to introduce every topic from where it starts to where it ends, and then we go to questions. So the aim of introduction is because I want you guys to know the whatever that we'll be talking about. You need to understand the basics, what governs that particular topic. So yeah, that's how my lessons are going to take place. And thank you, guys, thank you again for watching the video, and please don't forget to share. I played my part, which is teaching you guys the part. So what you guys can do is to help me to at least reach as many learners as possible. That is the aim of my videos. I want to impact, as many learners as in lives of many learners, man. I just want to I've been doing that, but impacting very less number of people. But now here's the platform for me to to share knowledge with you. So that's what I'm doing. And please don't forget. Thank you.